more motion problems. After this last quiz, I decided that we needed to do some problems involving gravity. So, take a look here. We have the height of a projectile. Here's the formula. This number right here, this is going to represent our acceleration due to gravity. We come up with that number. As we know, gravity pulls objects at 32 feet per second squared. So we take half of that to get the acceleration from gravity, which is right here. The acceleration from gravity is going to be 1/2 of that, and that's how we get -16. Okay, v sub 0, initial velocity, s sub 0, our initial height. So let's look at this problem. So a ball is thrown up from the top of a cliff, 250 feet high, with an initial velocity of 48 feet per second. So basically all we have to do is plug in our numbers. So we're going to have our height in terms of t as -16 t squared. Our initial velocity, 48 t, plus our initial height, which is 250. And that's going to represent our height in terms of t. That's our rectangular equation. Alright, let's draw a sketch of this. So we're going to put our height over here in terms of feet. We're going to put our time down here in terms of seconds. And it's a ball that's thrown up in the air, so we're going to have to think, well, let's see, 1, 2, 3, 4, 5, 6, that's t. And then our height, notice it's going to be thrown, initial height 250, and it's going to be thrown, so it's not going to go too much higher than that. So let's just go by hundreds. 100, 200, 300, 400, 500. 1, 2, 3, 4, 5, 6. 100, 300, 400, 500. And if we're going to sketch this, we're going to start out at 250. And this is not necessarily the path of the ball. Remember, this is the height of the ball in regards to time. So the height of the ball is going to increase, okay, and then decrease. Something like that. Just sketching what I think that might look like. Okay, so now we want to find the maximum height of the ball. So I'm going to go ahead and plug it in. I'm going to just plug it in without the t. Just plug it in with an x and a y, because we're just finding height. Okay, so second, calculate. I want the maximum. So I'm going to go left of the maximum. Going to the left of the maximum. Enter. Go to the right of the maximum, enter. So when x is 1.5 or 286 feet. So 286 feet. That's your maximum height. Okay. Now it says, when is the ball 282 feet above the ground? Well, using our calculator, we go to y equals. We want the height to be 282. Graph it. Alright, so pretty close here, so I'm going to go ahead and zoom in here a little bit. So I'm going to zoom in. Move your cursor to where you want to zoom in. I want to zoom in right in this area. Enter. That's quite the zoom there. Okay, we're going to do our intersection. So second trace, intersect. So this first curve on this side, go close to it. Enter, enter, enter. So when we're at 282 feet, x is equal to 1. So 1 second. And it'll be at 282 feet. That's on the way up. We want to go on the way down. So we're going to go over by this curve, this intersection. Enter, enter, enter. And again, we're at 2 seconds. So 1 and 2 seconds. The ball is 282 feet above the ground. When does the ball hit the ground? Alright, let's zoom back to a standard window. I did not want to do that, but here's where the ball went back to a standard window, and it messed it all up because I had set my window up so that it would be right. X minimum 0, X maximum 10, Y minimum. I'm going to go a little bit below the ground, and we know the maximum height is 286, so I'm going to go up to 300, go by 25s. Got a nice graph. Ball hits the ground right here, so I'm going to calculate my 0, and left, enter, then go below ground, enter, enter. Alright, so when y is 0, 5.728 seconds. Okay, alright, let's write the parametric equations to illustrate the path of this ball. So, made a mistake, guys. Write the rectangular function. What mistake did I make? Yes, rectangular is in terms of x and y. And I did this one in terms of y and t. So I made a mistake. We need to change our t's to x's. Okay? So we're going to take this and make it into parametric. So we're going to have x equals t. That's our, remember, our independent variable is what gets the t. Then our function gets the t as well. So much easier when you have a formula, right? Alright, let's set up a window now. So first thing we're going to do here is we're going to go ahead and go to mode, change it to parametrics. Okay, window, time minimum 0, time maximum, we know it hits the ground at 5.86, so we're going to go to 6. We usually just default to 0.1 for our step. Our x minimum is going to be 0. Our x maximum is going to be 5. Okay. Let's see. Is there any horizontal motion? Let's think about the question. The question said that the ball is thrown up. Up. Okay, so there is no horizontal motion happening here, only vertical motion. So we're going to go ahead and make x a constant. So let's just pick a number for t. Let's just pick a number. Okay? And so we're going to, at 3, we're going to see a ball shoot up in the air. Okay? We could have picked 2, and the ball would have shot up in the air here. Okay? Could have picked 1, the ball would have shot up in the air here. Okay? So now y min is going to be 0, and all the way up to, we know it's going to hit 286. So let's go to 300. Okay, again, t min 0 to 5, just so that we can see a little window here, a little space. 1, 2, 3, 4, 5. Okay, so I set up my scale on my horizontal, scale on my vertical height. Our ball is going to start at 250, so we put it at 3, so at 250 it's going to start right here. It's going to go up, and what do you think it's going to do next? It's going to go down to the ground. Let's watch it, okay? So again, make sure you have those in. Make sure your window is set up properly as we have those numbers. I went to 400 instead of 300, I don't know, doesn't matter. And let's graph it. Did you see it? It went up and then went back down. Let's go over here and let's change this so we can watch it. There we go, up and down, so we can actually see the ball going up and going down. Okay, next question. Trace your graph. How do you know when the ball is falling? Well, if we press trace, okay, and we go up, going up, watch the Y, we're going up, 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 up. Oh, what just happened? Going down. So we know the ball is falling when the Y values change from increasing to decreasing. Maximum height of the ball, we had seen that at, let's go back this way, 286. That's your maximum height, 286. We're looking right here at this number. Okay? And that's when time is 1.5 seconds. So let's go ahead and go down. We want to know when it's going to hit the ground. So watch your Y value. We're looking for 0. So it's actually going to be between 5.7 and 5.8. So 5.7 to 5.8 seconds. Okay, that's probably going to help you finish that last problem on the quiz. And this is the assignment that goes with these problems. This assignment will be due on Monday. Have a great day. Bye-bye.